Good evening, everyone. Welcome to webinar series conducted by 360DigiTMG. So, in today's session, you're going to see one interesting and important concept, which is called RAP concept, which is Retrieval Augmented Planning. Now, instead of focusing too much on RAP concept, we have taken one use case, and I'm going to bring in you how we will solve this concept with the help of hospital chatbot. Now, as you can see, the term indicates it is long-term reasoning. So here, when I introduce RAP, okay, with LLM, I can sequentially increase the contextual part of search in LLM concept. Now, so moving ahead, okay, 1 minute. Yeah. So the context will be what are the challenges that a normal LLM will face when a RAP concept is not introduced, and what is a true meaning behind retrieval augmented planning. Okay, so what was possible with the earlier pre-trained model and what will be possible with RAP introduced LLM model, and how am I going to improve an hospital chatbot performance, and how we are going to implement it on a hospital chatbot. Now, what are the challenges? Okay, what are the challenges a normal pre-trained LLM will have? It will be trained on more and information, okay, more information throughout the world, which is lagging what? Personal context towards hospital. That is first thing. Because of that, it cannot do good amount of reasoning. Then it will hallucinate a lot. Okay, it will try to give you too much of inaccurate informations that should not be present in your current hospital management system. Static knowledge. Okay, so when I say static, the pre-trained LLM will not be aware of what is the hospital's patient's record or hospital policy or hospital drug databases. So these are some of the challenges with respect to static. Okay, that is pre-trained LLM. Not only that, when I give a complex query, okay, when I'm giving a very complicated query, the query is composed of 3 lines, 4 lines, then it cannot identify that and it cannot give me a better answer. So, which is where it is struggling most. So, these are some of the challenges, okay, when you use a pre-trained LLM model. Now, moving ahead, what is retrieval augmented planning? Now, retrieval augmented planning has nothing to do with LLM, but this is one logic. Now, what kind of logic this is? It introduces a concept called DAG, okay, directed acyclic graph. Directed acyclic graph. When I say graph, we will have nodes. Nodes will have an interlink. Now, one important focusing part of retrieval augmented planning is when I give a context, it can go to a node, it can identify the links associated with that query. If it is not relevant, it will prune. Since we are bringing in graph concept here, pruning is a part of graph concept. So whereby it will not consider irrelevant informations. Okay, and it can search and identify the updates related to external documentations also. So whereby it will give us a trustworthy answer, and up-to-date answers also you can expect. Okay, so most important thing, irrelevant information can be neglected. Okay, it can break whatever complex queries you're trying to give, and whatever queries you are searching, it can possibly extract the latest updates and give you a trustworthy answer. So this is one of the interesting criteria when it comes to RAP. Now, this is something we are already aware of. What your pre-trained LLM weakness is, okay, it does not have the context, relevant context. Okay, it will have too much of hallucinations. Always outdated concepts will be there. Okay. You cannot implement too much of complicated queries. Irrelevant data will be too much, okay, in your pre-trained. Now, when I add RAP with this, how it is converting my LLM into a more complicated and efficient prone LLM. So here what it does multi-turn dialogues whereby DAG is introduced. Okay. All your hospital data along with the policy will be updated. Sequentially, it can identify the query, it can fetch the information. Whenever irrelevant information is there, it will prune that information. So, whereby you will get a more appropriate answer rather than hallucination answer. Now, how am I supposed to improve this chatbot? As I told you, okay. Now, consider this one. This is multi-step reasoning concept. So, what is the dosage scheduled for a medicine for this patient with this condition, and what are the side effects? So how many questions I'm asking here? Okay, I'm asking dosage question, I'm asking about a medicine, I'm asking about a patient, about the patient's condition, and about the side effects. Now if I used a normal pre-trained LLM, this complicated question it cannot understand and it cannot give me an exact answer. Okay, so it will lose the track. So without losing the track, okay, if I want to bring in a better answer, because a particular medicine will have a different dosage count for a particular patient, the policy of this medicine the government might have updated. So all these information it will now try to retrieve, okay, whereby it will decrease this hallucination concept. So this is how RAP enabled chatbot will be applicable for us. Okay. So moving ahead, coming to the workflow, you will retrieve the dosage. So how that query is trying to help you, how it is breaking it into DAG, that is directed acyclic graph. Check it. First dosage question. Post that dosage, it is moving to the patient condition. Post that it is understanding the side effect. Post, it is trying to give you the answer by combining all these three. So each and everything here is a cycle. It will move like this. It will move like this. It will move like this. So this is a cyclic concept. Now, how this is done? Okay, how you will do this on a real world aspect. So RAP is always introduced when you are using an infrastructure, AI infrastructure. Ideally, LLM is a part of AI. And in cloud platforms, it is most predominantly. Okay. Most predominantly cloud, or if it is on-premise also, you can introduce this hospital chatbot onto that cloud or your on-premise. So you will define this directed acyclic subtask, okay, where you will provide a proper indexing to your vector embeddings, which contains all these informations related to the hospital, patients, drugs, all those stuffs. Then dynamic retrieval, okay, through the context we are setting in, it will try to fetch some dynamic data. If at all that query is not having anything related to the updated information, it won't do. But here, since we are talking about medicine, rules and policy updations will be there, so that will be fetched. And based on the previous slide, it will subdivide it into multiple tasks and it will prune the irrelevant information, whereby you will see the answer. So this is a continuous process. This is a continuous process whereby you can fix this and orchestrate and monitor the efficiency of the LLM, okay, with the help of retrieval-augmented planning concept. So thank you all. Hope you had a great learning from this. We will see on next session.